Lab assignment number 3 is corresponding to Prolog, okay, where we are actually using knowledge base 1, 2, 3, 4, 5. So installation of SWI Prolog and working with Prolog is lab assignment number 3, right? Lab assignment number 4 is actually a small expert system, okay. So I have already talked it about. In the lab assignment number 4, I like that, okay, everyone should write such kind of tiny expert system, okay. This is the tiny expert system, okay, in the Prolog, where we can use this small expert system, okay, for diagnosis of the childhood diseases corresponding to the patient Charlie, because Charlie is having symptom of fever, rash, headache, okay, and runny nose, and we are having such kind of 4 rules, okay. This is called as a rule, okay, in Prolog, right? Right hand side is actually set of symptoms, okay, and this comma stand for and over there. This is called as rule head. So I believe that, okay, in the rule head, if right hand side, okay, of that particular rule is true, okay, so if the patient is having fever, cough, conjunctivitis, runny nose, okay, and rash, then we can believe that, okay, patient is having the suffering from the measles, right? So we have written 1, 2, 3, and 4 rules, okay, corresponding to measles, German measles, flu, okay, and chicken pox. These are all the childhood diseases, right? So after this, okay, how to query the Prolog? So let us try to uh, demonstrate, okay, one particular program. I hope that many of you have already downloaded SWI Prolog. I have already sent you the email, okay, corresponding to that, okay. So when you have installed SWI Prolog, you will get such kind of icon, okay, on your desktop, right? Double click it, okay. Now I'm consulting the file, consult charliediagnosis.pl, okay. This is my file, okay, I have created. I will also open this particular file so that you can see it. Okay, so file, go on edit, okay, and I can open this particular file, okay, in the new editor, new window, editor window. Okay, so we are having the 4 rules and 1, 2, 3, and 4 facts. These are called as facts, and these are called as rules. Okay. Now, what need to be learned, okay, in the prologue? Okay, in the prologue, we need to learn that, okay, how to create such kind of knowledge base. Knowledge base contains set of facts and set of rules. Okay. Then after creating, how to use it, how to query the prologue. Okay, and understanding it. Okay, that how prologue reasons, that is more important. Okay, very crucial part of learning. Okay. So we have already consulted this particular file. Okay. Suppose I want to type a query. Okay, that कि Charlie को क्या हुआ है, right? Okay. So I can write this particular query in this particular way. Okay. Hypothesis. Instead of patient. Okay. I need to provide name of Charlie. Charlie. Okay. And provide one particular variable. Okay. Because I like to know. Okay. The name of the disease Charlie is suffering from. Okay. So I will write capital X. Anything which is written in a capital manner, that is considered as the variable. Okay, so complete this. Okay, and please put a dot. Every query, okay, in the prologue, okay, ends with a dot, right? Now hit the enter key. So prologue has responded that, okay, the child is suffering from German measles. How? It has taken this particular query, okay, as input, okay, and it will find out the first match of hypothesis. Okay, so in our uh, source file, the first match of hypothesis is this, okay, and the first argument we have provided, okay, as a Charlie, and since this is a capital P over here, patient, okay, so patient is a variable name, so Charlie is bound to, okay, this particular patient, okay, and product will try to prove that his patient is suffering from measles, okay, now patient is bound to Charlie, okay, so product will try to prove that Charlie is having hypothesis of measles. So to believe this rule head, okay, rule body must be true. Okay, so rule head and rule body is separated by colon followed by a dash. This is the rule body. Okay, and in the rule body, okay, it will try to prove, okay, the first clause. Okay, and that is corresponding to patient is having symptom of fever. Once patient is bound to Charlie, okay, this can be interpreted as Charlie is having symptom of fever. Okay, so product will try to find out, okay, the first batch of symptom. It is here. So, okay, patient is already gone to Charlie, okay, and Charlie is also having a fever, okay, so it is correct, it is true, okay, because we found a match. Now this comma is and, so product will try to find out, okay, the second symptom, okay, that where Charlie is having the cough, okay, but see that, okay, in all four matches, 1, 2, 3, and 4, okay, the cough symptom is not there, okay, and hence this particular clause is evaluated to be false, okay, by the product, okay, and since it is handled with multiple symptoms, right? So the rule body is evaluated to be false, and hence, okay, this is wrong, okay, that the problem don't believe that, okay, Charlie is suffering from measles, okay. So it will backtrack and will find out, okay, another match with hypothesis, okay. This is the second rule now, and patient is again bound to Charlie, and we are interested, okay, to find out, okay, whether Charlie is suffering from German measles or not, right? Similarly, okay, it will do this search, okay, and matching one after the another. The fever, headache, runny nose, and rash, all of these particular four symptoms, okay, they are matching, okay, and hence, okay, X is said to German measles, okay, which is nothing but the second argument, okay, to this particular hypothesis, right? In this particular way, okay, product works, okay. So this is lab assignment number 4. This is lab assignment number 4. What about lab assignment number 5? Lab assignment number 5 is actually corresponding to perceptron learning algorithm. Perceptron learning algorithm, okay. Now I will describe briefly, okay, that what is supposed to do over here, okay. Can you see my slide? Please read my.
Yes, sir.
Yes, sir.
Yeah, yeah. So this is general neuron model. Okay. So Mac Kuloch and Walter Peet. One of them is logician and second one is neurophysiologist, right? Doctor, specialized doctor, right? They have done a lot of study, okay, that how neurons, okay, in the brain works, right? And they have proposed actually generalized and simplified neuron model. It is called that general neuron model, or it is also famous by their name, Mac Kuloch Peet's model. Okay. So in that model, okay, I have shown it here, okay, the schematic of only one neuron. Okay, it is having the cell body, okay, and we are having several input lines, okay, or input channels coming to this particular neuron cell body, okay, and what is provided at an input, okay, that is nothing but actually a n-dimensional pattern, okay, corresponding to various features, okay. So x1, x2, x3, x4 up to xn, these are the n-dimensional features of a pattern. For example, a pattern can have height of x1, weight of x2, humidity of xn, and something like that. Okay. So input to a neuron is considered as, okay, n-dimensional pattern. Okay. And since this neuron is having n input channels, right? Okay. Now see that there are weights on each and every input channel. Okay. And that weights, okay, are considered as the properties, okay, of this particular channels, right? This is actually representing the chemical property, right? And we can represent them, okay, in terms of real numbers, 0.5 minus 0.1, 2, okay, something like that, right? So we can initialize the weight, okay. So a neuron is having a weight vector W containing n components, okay. If it is taking n dimensional input, W1, W2, W3, Wn, right? We are providing n dimensional input pattern. This is input pattern, okay, also called as input vector. Input vector represents a pattern in terms of n dimensional features. For example, पहला feature है x1, दूसरा feature है x2, okay, and something like that, right? We are providing this, right? After providing the input, okay, and by utilizing weights, a neuron will calculate its internal activity level, okay, called as net input. Okay, so net is actually summation of I is equal to 1 to n wi xi. So this is weighted summation of input. X1 multiplied by W1 plus X2 multiplied by W2 plus X3 multiplied by W3 plus so on up to Xn multiplied by Wn. This is called as weighted summation. Okay, and this weighted summation is considered as net input, okay, or internal activity level of a neuron. Right. Now see that what is happening, okay, at this particular neuron body is also called as soma, okay, in the biological neuron. Okay, in theory we will cover all these things, okay, theoretical stuff in a separate manner. The main work of soma is that, okay, it will integrate, okay, and take weighted summation of x and wi, right, and from the net input or internal activity layer of a neuron, it will generate the output O. So output O is calculated as f of net, okay, where f is actually a function called as the activation function of a neuron, right? And there are various kinds of activation functions. For example, unipolar, they contains only positive values or only the negative values. Bipolar contains both positive as well as negative values, okay, as the output, right? So these activation functions can be continuous as well as discrete, okay? And by using these four combinations, right, we can have unipolar continuous, unipolar discrete, bipolar discrete. Okay, four activation function types, okay, are possible, right? So based upon what kind of activation function, okay, we are using, okay, so the behavior of neuron, okay, may be different. So this is actually the signum function, okay. I can use signum function, okay, as a kind of activation function of a neuron, and it is bipolar binary. Bipolar means what? It is having plus and minus sign both, right? Okay, it will provide the output with plus and minus sign both. And binary stand for, okay, it provides only two values, right? Either plus one or minus one, okay. So this is called a signum of net, okay. In the perceptron learning, we are using signum function, okay, as the activation function of the neuron, right? So we have to calculate the net, okay, by using weighted summation, and net is given to signum, okay, as an input, okay, and we can get output O as f of net is equal to plus one if net is greater than zero, and minus one as output of the neuron if net is less than zero. Okay, so it is undefined, okay, for net equal to zero, right? This is called as bipolar binary activation function called as signum. Okay. Now, what is the learning philosophy? How neuron learns? Okay, in brief, neuron learns, okay, by updating its weight vector. ये जो मैंने weight vector यहाँ पर दिखाया है जनरल neuron model में weight vector, okay. So these weights, okay, they are subjected to change, and neuron try to adjust the weights in such a way that, okay, error in actual output and computed output of the desired output and computed output of the neuron must be as small as possible. Ideally, it should be zero. Okay, ideally, it should be zero. So we are uh, training the neuron in such a way that, okay, in the process of training or learning of the neuron adjusts its weight vector, okay, or weights, okay. So let us say that, okay, we have initialized the weight vector, okay, close to zero. Okay, so before starting of the training, we need to initialize weight vector close to zero, right? Containing plus values as well as minus values. For example, minus 1.5 plus 0.12, okay, something like that, okay, such kind of values, right? And then from this particular weight vector, okay, because I can plot weight vector as a point, right? Okay, then I can move ahead, okay, and I have to adjust the weights in such a way that, okay, error in the desired output and actual calculated output, okay, within neuron should be actually minimum, right? And after a lot of training, okay, I will reach at this particular point, okay, I will get this kind of weight vector where error is minimum, okay. And so here I declare that that particular neuron has trained over there, okay, because it is getting least or no error at all, okay, in the desired output and actual output, okay. So the difference between desired output and actual output is zero, okay, for all the input patterns, right? This is the basic philosophy of learning, okay. Such kind of training is also called as gradient descent. Gradient का मतलब होता है slope, right? And descent means in the negative direction, right? This is the basic philosophy of learning of a neuron, single neuron. So I have plotted error surface over here, okay. Now suppose I have started with initialized weight vector from here, okay. Then in which direction to move, it is actually determined by error surface, okay. So in this way, okay, I have to move, I have to update the weight vector so that, okay, I will get lesser and lesser errors, okay, over there, right? And at last, okay, I will reach it over here, right? Okay, and here my training halts, okay, because I am getting the least or ideally zero error over there, right? So my training can be halted over there. Yeah. Immediately come to the perceptron learning rule, okay. So it is invented by Rosenblatt. Rosenblatt was a psychologist. Okay, so please note that the field of artificial neural network is actually uh, pioneered by doctors, physiologists, logicians, psychologists. Okay, so diverse populations, okay, they have contributed, okay, in the development of artificial neural networks. Right. It is proposed in 1958. Okay, and it is supervised learning. Means what? Desired output, okay, for every input is actually known to us. Okay, and learning signal R in the perceptron learning rule, okay, is difference between the desired output and actual output. Since it is supervised learning, desired output dk for the kth input pattern is known, and OK is calculated, okay, by using weights of the neuron. Okay, and if dk is equal to OK, so learning signal R will be equal to 0 over there. Okay, and perceptron learning rule can be stated in the mathematical form like this: W of k plus 1 is equal to W of k plus delta W. W of k plus 1 is, okay, weight vector W of a neuron, single perceptron, at the k plus 1th instance is equal to weight vector of that neuron or perceptron at the kth instance plus delta W. And delta W is actually a small increment, okay, suggested, okay, in the weight vector. And this delta W is calculated as C multiplied by R multiplied by input vector X given at the instance of K. So this K and K plus 1 should not be regarded as powers of W, right? They represent instance. And so this is the weight vector at the K plus 1 instance. This is the weight vector, okay, at the K instance, okay, something like that, right? Now, what is C, R, and this input vector X, K? Xk represent input pattern applied at the K instance. R is nothing but what? Learning signal. That is difference between dk minus OK. That is desired output and actual output. Okay, and C is actually called as learning rate. C is called as learning rate. Okay, generally it is set to greater than 0, 0.51, 1.52, okay, something like that. Right? So the final weight updation in the perceptron learning rule can be done in this way. I can calculate updated weight vector W of k plus 1 by using old weight vector k W of k available at the SS k plus, okay, this particular fraction C multiplied by dk minus OK. So this fraction is actually multiplied with every component of the input vector X provided at the k instance, right? And then we will get actually a n-dimensional vector, okay, as a part of this particular second factor over there, right? And that is added, okay, in the old weight vector, okay, to produce the new weight vector W of k plus 1. Right? In this way, perceptron learning rule progresses. Okay, so C should not be too large and too less. Okay, yeah, this is the problem. Okay, that we should solve, okay, with the help of single perceptron learning. We need to write a code corresponding to this. It is very easy. Okay, it is very trivial. Okay, assume that we are using initial weight vector W0 and it contains 1 minus 1 0 0.5. Okay, these are the four components. Use perceptron learning rule to update weights, okay, for following three inputs. C is equal to 1, that is learning constant is equal to 1. And we have to use signal function as the activation function. And desired outputs are given 1 minus 1 1. Okay, means what? X1 is our first input pattern. Okay, it is the input vector containing 1 minus 2 1.50. Okay, so desired output for the first input pattern X1 is 1. Desired output for second input pattern X2 is minus 1. And desired output, okay, for the third input pattern X3 is plus 1, okay, respectively, right? And it is asked that, okay, we are supposed to use signum function. So we know that signum of net is equal to plus 1 if net is greater than 0, and minus of 1 if net is less than 0. And how we are calculating net? We are calculating net, okay, by using weighted summation of WIXI. And this net is provided as input to the signum function, and output O is equal to signum of net. And we are updating weights, okay, in this particular, right? Okay, now I have done this particular calculation, okay, in one specific file over there. Okay, yeah, this is the file x1 x2 and x3. I have used d, a vector d, as a vector that is storing the desired outputs, okay, of the neuron, okay, for first, second, and third pattern. So desired output I want is plus 1, okay, for x1, minus 1 for x2, and plus again plus 1, okay, for x3. Activation function is this, right? Initial weight vector given is W0, that is 1 minus 1 0 0.5. Now in the step 1, we have to apply first input pattern X1, okay, and we have initial weight vector W0. So I have to take dot product of X1 dot W0, okay, and this is how, okay, I can get the net input, right? So net input is, okay, component wise product, okay, so 1 multiplied by 1, okay, plus minus 1 multiplied by minus 2 multiplied by minus 1, 1.5 multiplied by 0, 0 multiplied by 0.5, right? So I will get net is equal to 4.5, okay, for the first input pattern, okay, and by using W, right? Since net is greater than 0, O of signum of net is equal to plus 1, right? Now this is called as O. O means what? Actual output calculated by the neuron, okay. And what is the desired output, okay? For the first pattern is 1. So desired output is equal to actual output computed, okay, over there, right? So in this particular case, delta W, that is change in the weight vector, C multiplied by D minus O. D minus O stands for desire minus actual output. Okay, so it is 1 minus 1 comes out to be 0. Okay, and we have applied x1 over there. Okay, so x1 multiplied by D minus O multiplied by C. C is 1, D minus O comes out to be 0. Okay, because desire and actual output are same exactly. And this is the input pattern applied. Okay, x1, right? Now we have to multiply uh, by 0, okay, to each and every component of x1, okay, I will get delta W as 0. So from this, if desired output is same as actual output of the neuron, we are not going to update the weights, okay. So W1 will be actually W0, okay, plus delta W, okay, which is 0. So it is exactly equal to W0, right? So I will consider this updated weight vector W1, okay, for application of next input, okay. So we are using W1 and I have to apply the next input pattern, that is X2. Okay. Then again we have to calculate net as W1 multiple W1 dot product of X2, right? And net is calculated as 0.75. So net is greater than 0. So signum of 0.75 is equal to plus 1. But see that, okay, desired output is actually minus 1. For second input pattern is minus 1. Okay. So we need to calculate, okay, the delta W, that is change suggested in the weight vector. That is 1 multiplied by D. Desired output is minus 1 minus this O, okay, that is plus 1, and it is multiplied by x2, right? Okay. So we get delta W is equal to minus 2, 1, 4, and 3.0, right? So I can calculate W2, okay, is equal to W1 plus delta W. So W1 is this, okay, and delta W is we have calculated as a small change suggested in the weight vector. So W2 is equal to minus 1, 0, 4, 3.5, okay. Now this delta, this W2 is used, okay, when we apply the third pattern x3, okay. So net can be calculated as, okay, the dot product of x3, third input pattern, with respect to weight vector W2, and we'll get net as 1.25. Okay, so net is positive, that's why O is positive, and desired output of for third pattern is also positive. So D minus O will be 0, and thus delta W will be evaluated as 0 vector over there. So we get W3 is equal to W2 as it is, right? So after application of first, second, and third input pattern, okay, we get output vector as a W3 over there, right? So in this particular way, now see that we have applied x1, x2, and x3 once only, but error is not 0. Okay, I cannot say that, okay, my neuron is trained now. I cannot say that, okay, perceptron is trained now, right? What to do now? This is called as one cycle. So I have to repeat this particular thing, okay, up to, let us say, n number of times. Value of n can be 50 or 100, okay. So that, okay, I have to halt the training unless and until error is 0. Error is 0. Okay, so there should not be error in all the patterns, okay, which are applied, okay, to that particular single perceptron. Okay, so D minus O must be 0 for all those input patterns, right? So we need to write a code for the same problem. Okay. Now I am showing you, okay, the C code for the same problem, okay, which I have written. Instead of using three input patterns x1, x2, and x3, I am actually writing this in the format of matrix. This is the first row x1, this is the second row x2, and this is the third row. This is the second row, and this is the third row. Correct? X1, x2, and x3. Okay, so I have formed actually matrix over there. Okay, so first row is actually x1, second row is x2, and third row is x3. Okay. Initial weight vector W0 is equal to 1 minus 1, 0, 0.5. Okay. Desired output D is set to 1 minus 1 plus 1. Learning rate is equal to 1. Okay. Float is declared as a net and output. Okay. They are declared as float. Okay. And I am using error now. Okay. Because when to exit the training is actually based upon error. Okay, so I will enter again into this particular while loop. Okay, before starting the new cycle. Okay, this is actually the starting of new cycle. We are using for loop okay, to start the new cycle of the training, right? Or that is also termed as epoch. Okay, so error is set to 0, and then okay we are actually calculating okay net okay for the first input pattern by using the weight vector w, right, and we are computing output. If the output calculated is not equal to desired, then only okay we are updating the weights, otherwise no. And we are actually summing error okay occurring for each and every input pattern or input vector over there, right? Okay, so when we complete okay one iteration of the for loop, okay, that is called a cycle error. This error is called a cycle error. And when cycle error is 0, it means that we got all the actual outputs computed by the neuron same as the desired outputs. Okay, so even at the end of this particular cycle, okay, or one epoch, we'll get error as a 0, right? Then we'll come out of this particular while loop, okay, and we can print now okay the updated weight vector. Okay, so in this particular way okay we can write C code okay, corresponding to conceptron learning mode. Okay, this is single conceptron, right? Signal function is called okay and it can be written in this particular way. Okay, so this is very trivial. Okay, but problem is that okay we need to find out okay that after how many epochs okay what is the error okay something like that. Don't expect that okay you will get zero error. Okay, error can be sometimes very less, right? But obtaining zero error may require actually very large number of epochs. So you should halt your training again after completion of let us say 50 epochs, not more than 50, right? Fine. Okay. Is there any question here, please? So both of these documents okay, they are actually uploaded on viewing. Is there any question? Please answer.
No, sir.
No, sir.
Oh, okay, so fine. I'll go for sixth lab assignment. That is again a very trivial issue, okay? But we need to understand it conceptually. That is the thing about okay, implementation of a fuzzy set for numbers close to 5. Okay, now see what kind of sets set theory we have already learned is proposed by George Cantor. Is called as classical set theory. Okay, or it is also termed as crisp set theory. Okay, because in that particular set theory we are actually using a membership function. Okay, and that membership function is actually used to answer the question. For example, there is a set A, and set A contains let us say two elements, one and two, right? Okay. So if I ask you a question, is two a member of the set? You'll say yes. Okay, because two is actually there again the set A, and if any element X is belonging to A, okay, we will get membership value of that particular element as 1. Okay, so for each and every set which we already learned, it is associated with its membership function. And on the basis of membership function, okay, we are actually determining whether 2 is element of the set or not, right? So if membership of 2 in element A is 1, I say that okay, X belongs to A or 2 belongs to A, set A. Otherwise, okay, if there is an element X, okay, which is not belonging to A, the membership value of that X, okay, in the set A is equal to 0. So this particular set and its membership function provide only two possible values, 1 and 0. 1 if X belongs to A and 0 if X does not belong to A. Right? So fuzzy sets they are generalizations. Fuzzy sets are generalizations of our crisp sets or classical sets. Right? And there is an obvious application of fuzzy sets. Okay, that because many real world patterns they never match perfectly, right? And in designing pattern recognition system, it actually creates a lot of problems. For example, I have created a fuzzy set corresponding to all the characters written by 100 write-ups, okay, and it is 1. I will create another fuzzy set okay, corresponding to the handwritten character 8. Now suppose I have a test image and I am interested to find out match, that whether the input image or test image is matching more with one or eight, right? So what I will do, I will calculate the fuzzy membership value of this particular test image, okay, in the set corresponding to A. Let us say it is 0.15. Okay, that membership is in between 0 and 1, inclusive. Means what? Okay, it can take membership value as +1, it can take membership value as 0, and it can assume any of the value that lie in between 0 and 1. Okay, I will apply test image, okay, and find out the membership of this particular pattern, okay, in the fuzzy set corresponding to it, and I will get 0.2. Now, this particular membership value can be used to reason similarity. So, by using this membership value, I can say that, okay, the applied test image is more similar to A to P than 1. Okay, but please note that, okay, the test image doesn't fit perfectly in any one of the previously learned patterns. But still, okay, we are able to reason based upon the similarity. Okay, based upon the similarity. Okay, so I can say that test pattern applied, okay, is more similar to A to B than that of 1. So this is application of the policy. Okay, yeah. So this is the slide, okay, which actually talks about that how we can define a fuzzy set. So defining a fuzzy set means what? We're supposed to define the membership function of that particular set. Okay. So mu a of x. Let us say that, okay, we are calling this set, let a be the fuzzy set, okay, of a number x, okay, close to 5. So we are measuring membership of x in fuzzy set A, and mu stand for the membership. It is read as, okay, mu a of x, okay, is equal to 1. Now see that if that number x, that is the input number, okay, if it is exactly equal to 5, then I want to provide the highest membership value of 1. I have to provide highest membership value of 1. Okay. Now when if this condition is true, okay, what is that condition? Gamma. Gamma is called as sensitivity parameter and is greater than 0. It is user defined parameter. I can set it as 1, 0.5, okay, something like that. After gamma, okay, we are having one absolute value, right? Now see that if I have inputted here, okay, x is equal to 5, then maximum of 5 by 5 comma 5 will be 5. So 5 by 5 becomes out to be 1. Similarly over here, 5 divided by max of x comma 5 will be 1 by 1. So 1 minus 1 comes out to be 0. 0 multiplied by gamma comes out to be 0. It means that when input pattern or input number x is exactly equal to 5, okay, I am getting this particular product, okay, as a 0, okay, this factor as a 0, okay, and I want to provide the highest membership value to that, okay, because x is exactly equal to 5, right? Assume that, okay, 5 somewhere, right? If x is exactly equal to 5, I will get highest membership, right? Okay, but if I am moving away from 5, okay, so towards this side or towards this side, membership value, okay, must decrease. Membership value must decrease, okay, as we are going away from 5, membership value, okay, should decrease, okay. This is plot of the membership function, right? Okay, so in this particular way, we can actually use the same factor over here. Now if the value of the factor is greater than 1, I want to put membership, okay, to that particular x as 0. And if this particular factor is equal to greater than 0 and less than or equal to 1, then I can provide, okay, membership value as 1 minus, okay, this particular factor. If this factor is actually 0.3, then 1 minus 0.3 comes out to be 0.7. Okay, so more membership value will be actually allocated. Okay, if lesser value of this factor over there. If this factor is zero point 0.7, okay, then 1 minus zero point 0.7, that comes out to be 0.3. Okay, so based upon, okay, how we are going away from the 5, right, we get lesser and lesser membership. Okay, now if I reduce or if I increase value of x further, right, okay, then we are getting all those elements, okay, we are having membership as 0. Same is the case, okay, from this number, from this value, it was left. So all of these values of x, okay, they assume the membership value as 0 over there, right? Now what is gamma? Gamma is actually sensitivity parameter, right? And gamma actually defines a support of the fuzzy set. This set of all possible values x, where membership is greater than 0. So this set is called as support set of the fuzzy set. And core part of the fuzzy set is a set containing all those elements assuming highest membership value. So core part of the set contains only one value 5 over here, and support part of it contains all those set of x, okay, from here to here, okay, where membership is greater than 0, right? So if I increase the value of gamma, support part will reduce, right? If I say value of gamma is equal to infinity, your fuzzy set will collapse with crisp set, okay, and your set will provide only two possible values, 0 or 1, right? That's why fuzzy sets, okay, they are generalizations of the crisp set, right? So you need to write a code, okay, only for this particular logic. Okay? Your program will write a code for mu a of x, okay, by using this logic, okay, and based upon value of x, okay, it will provide me membership value, okay, that is mu a of x in between 0 and 1, right? So print values, okay, for some values of x, for example, x can be between 0 to 10, 0, 1, 2, 3, 4, 5, 6, 7, 8, 10, right? I can provide any value of x, right? So for x is equal to exactly 5, your program should provide me membership of 1 over there. Fine. Is there any doubt, any question? So you can actually go ahead, okay, and can complete the lab assignments, right? On VOLP, I have already uploaded all the video lecture links. I repeat, on VOLP, go to my course, okay, and in contents directly, okay, you can find out, okay, all video links, okay, corresponding to my lectures. I suggest them, okay, to brush up your concept corresponding to lab assignments, okay. So I think we should halt here. So I have talked about, okay, the lab assignments number 3, 4, 5, and 6. Any doubt, any question? Devang, Dishan,
No, sir.
Kirti.
No, sir.
Yeah, because remaining all lab assignments, okay, they are very trivial. Chote chote hai, okay. So complete it, okay, and your lab examination date is 22 of November. So you don't have much time, okay. Complete lab assignments as soon as possible. And I must answer one question. What can be the format of, okay, lab examination? Now see that, okay, lab questions will be totally based upon, okay, the 6 lab assignments, okay, which you have done, okay, but there can be a small difference, okay, and we'll check your understanding of the concept also, right? I will not ask, okay, write down the whole code for A star, okay, on solving it puzzle. I know that, okay, this is very bulky lab assignment, right? It may require several days, right? So in parts, okay, I can ask, right? Some of the portions, okay, I can ask about it, okay, and you need to write a code, okay, corresponding to that one. Your lab examination will be of 2 hours, right? I suggest everyone, okay, please install and download and install SWI Prolog, okay. Make yourself familiar, okay, with how to create knowledge bases in Prolog, how to query them, okay, something like that, right? One more thing, that your lab exam is a duration of 2 hours. So we'll ask only those questions, okay, which can be solvable within the span of 2 hours. Don't worry, don't bother. It is my botheration. Okay, that it should not be much complex. That it may
So can we
require. Yeah, yeah. Please, Ashish, go ahead.
so can we use our own PC? Means our own laptop.
I don't mind exactly. Okay, but I have to find out. Okay, what is the rules and regulations, right? तो लैपटॉप लेकिन हमारे यहाँ पर कॉपी वगैरह करते हैं बहुत सारे लोग. I will check it out. But for Prolog, okay, you need to come with the pre-installed version of SWI Prolog, right? But for rest of all the lab assignments, I will check out, okay, what are our rules, okay, and both of us will abide by that. Any other question? I hope that, okay, now we can complete all the lab assignments. Okay, go ahead. Still, okay, I will continue with our theory lectures. Okay, according to our time, I may need, okay, some extra slots. Don't worry. I know that, okay, we are very busy. I will not trouble you much. Okay, but within the short span of time, okay, I have to talk, okay, regarding the central concepts, okay, of important topics. Right? Please refer my video links, okay, to see the lectures, okay, so that you can work at your own, okay, and can understand the concepts. Fine. Yeah, please type your roll number in the chat box. If you have any questions, okay, feel free to ask. Okay, I'm here for you. questions regarding theory examination, questions regarding your lab examination, your course project, CVV. Any questions, please?
Sir,
So
what
for
type
the
of questions will be asked in the theory exam?
Yeah, in the theory exam, okay, questions will require conceptual understanding, okay, and they are actually spanned across 6 levels of Bloom's taxonomy. Some of you might have been aware, okay, that we need to ask questions, okay, regarding different levels of learning. For example, okay, the first level is called as remember, just remember and recall, okay, without understanding. Second level is understanding. Third level is application. Fourth level is analysis. Then design, okay, and create. Okay, these are the 6 different levels, okay, of the Bloom's taxonomy. So your questions they are spanned across all 6 levels, okay, so that we can evaluate you in all levels of Bloom's taxonomy. Okay, so don't expect that, okay, remembrance and recall will help you to score my subject, okay, and remaining subject as well, okay, because we have to show that, okay, we have asked the questions, okay, which are spanned across all the 6 levels of Bloom's taxonomy. Good question, Abdul. So in the level 5, we are going to check, okay, your analysis. We are going to check your evaluation power, that whether a system is good, bad, okay, and something like that, right? So it really needs the understanding, okay, of the concept. But you can score also, okay? If you have learned my subject, okay, conceptually, then you can also uh, score my end semester examination. There is not much. Yes, any other question?
So will there be numericals in the written exam?
Yeah, of course. Without numericals, okay, how is it possible? So it is actually a very proper mix. So according to Bloom's taxonomy, okay, what is needed, we ask for them.
so the lab exam will be completely implementation based, or it could be like a pen paper exam also with like both.
No, no, no. Lab का मतलब lab. कीर्ति.
Okay, sir.
Yeah, you're supposed to write code, it execute होना चाहिए. But don't worry, huh? Suppose if you have implemented the concept in a very right way, but you are facing some syntax errors, okay, I will not provide you 0 mark. Don't worry. My evaluation is analog, not digital. 1 or 0 is an. Okay, so I will check it out. Same is the case, okay, regarding our lab evaluation. Lab assignment evaluate करना है मुझे. Okay, so every person has to create one folder, okay, named by you, okay, your batch and roll number. And please keep all of your 6 lab assignments, okay, over there. Okay, and forward that folder to me, okay, on email. So I will also check that, okay, are you getting some sort of errors? Yeah, fine. But I will provide you the marks proportional to how much you have written the code, okay, in a correct way. Conceptually correct है, but there are certain issues, okay, regarding syntax or semantics or something like that, right? Don't worry, you will get good marks, okay, but not full, but considerably higher marks. Okay. Any other doubt? Shreyash?